Right, now we'll move to the third worksheet, which has a little bit advanced problems on L'Hopital's rule. I'll start with the question number 3. That is, the limit of x squared minus ln 2 over x divided by 3x squared plus 2x. Now, as this is a fraction, let's see whether we have the conditions required for the L'Hopital's rule. Now, if we consider the limits of the numerator and the denominator separately, for the numerator we will have infinity squared. This becomes x squared becomes infinity squared, that is again infinity, and here we have ln 2 over infinity, which is 0, and ln 0 will be negative infinity, and along with this negative, this whole thing will be positive infinity. And here also we have infinity squared, which is a very largely positive number, and again here we have positive infinity, and all together numerator will give you positive infinity. And for the denominator we have, this becomes, as we have x squared, so it becomes infinity squared times 3 is again infinity squared. That is a very large positive number, so we can denote it as infinity. And for 2x, again it will be plus 2 times infinity, which is infinity. And so this is like infinity plus infinity. That means a very large positive number plus a very large positive number. So again this becomes a very large positive number. So the denominator will again be a positive number. So we have the condition required for the L'Hopital's rule. And okay, now as we have the condition satisfied, then we can get the derivative of the numerator along with the derivative of the denominator. And the derivative of the numerator will be 2 times x minus where to get the derivative of ln 2 over x, there are two methods that you can follow. One is you can directly differentiate this whole term, where you have, like for example, if you have ln of a certain function, and if you differentiate it, you will get f prime of over f. Or else what you can do is you can rewrite this term as ln2 minus lnx by using the logarithm rules. So instead of this term in the numerator, we can write x squared minus ln2 minus lnx, and then you can just differentiate them term by term. Either way, you should get the same answer. Now, by using any of these techniques, when you differentiate the numerator, you will get 2x minus 1 over x as the answer in the numerator. And for the denominator, you will get 6x plus 2. So, for this one, from the L'Hopital's rule, it says the limit of this is equal to the limit of the original problem. Now, see what will happen when you when you are trying to compute the limit of this second stage. Now, for the second stage, when you if you try the direct manipulation, you will again get infinity in the numerator and then infinity in the denominator. This becomes infinity. This becomes 1 over infinity, which is 0. And then altogether it will be positive infinity. And in the denominator also you will have infinity plus 2. This infinity, don't consider infinity as a number. It's just a notation for a very large positive state. Okay? Right. So, yeah. Now, here again we have the stage or the category required for the L'Hopital's rule. See, now in the very first problem, we had the suitable category for the L'Hopital's rule, and then when we applied the L'Hopital's rule, we didn't get a finite answer. Instead, we got a result which goes to the previous category, goes to the suitable category of the L'Hopital's rule. So what we can do is, we can once again apply the L'Hopital's rule. That means, just consider this as our initial problem. We can consider this second stage of the original problem as our new original question, and then just apply the L'Hopital's rule once again. So, when you apply the L'Hopital's rule one more time, for the numerator you will have 2 minus 1 over x squared and over 6. Right? I think this should be positive because of this one here. So, this becomes negative. Right? And for this stage, we can directly get an answer because this becomes 0 when you have infinity, when x goes to infinity. See, now to solve this problem, this original problem was a fraction, and then when we compute the numerator and the denominator separately, we had the suitable category. So we applied the L'Hopital's rule, but here when we apply the L'Hopital's rule, we end up in the same category. So we were able to apply the L'Hopital's rule one more time for this second stage. Then it was reduced down to a finite stage. Right? Okay, so let's practice this problem, this type, with the fourth question of this worksheet as well. Right? Now for the fourth question, what we have is the limit of x goes to infinity. We have to compute the limit of this term, x cube to the x cube times e to the power negative x squared. Right. Now here in this question, if we just try to come up with an answer by direct substitution, what we will have is this term will be infinity cube, which is again infinity, that represents a very large number, and here it will be e to the power negative infinity. In other words, this is 1 over e to the power infinity. This is actually infinity squared, but we can still rewrite it as infinity because infinity it's just a representation for a very large number. Okay? Right. So this 1 over e to the power infinity will be again a very large number. So basically what we have is, that we have here is 1 over infinity. That is, here we have infinity for this one, and for this term you will get 0 because 1 over infinity is 0. Right. So this is an indeterminate case, and also this is not a suitable category for the L'Hopital's rule. But I hope you can remember, now in our first video of this series, of this session, we did some sort of a conversion to a suitable category, right? We came up we came across these types of problems in that very first video, if you can remember. So in that sense, we have to do some calculations, or I mean some algebraic manipulations to rearrange this problem in a way that it gives the result for us to apply the L'Hopital's rule. Okay, right. Now, how are we going to rearrange this problem so that it gives us the result so that it falls under the required category? So now in this problem, if we just rewrite this one as x cube over ex squared. This is the same problem now. Don't try to change the original problem. This is the same as it was given in the original format, but just we have done some rearrangement. We are not going to change the original problem. Okay, right. Now here, if we just apply the limits, or if we separately compute the limits of numerator and the denominator, we will have, in the numerator you will get infinity cube, and here you will have e infinity squared. That means this is a very large number, and in the denominator also you will get a very large positive number. So this falls under the suitable category for our L'Hopital's rule. This is one of the suitable categories for the L'Hopital's rule. So now for this format, we can easily apply the L'Hopital's rule. When we apply the L'Hopital's rule for this one, it becomes 3x squared. When we differentiate it, it becomes 3x squared. And for the denominator, when we differentiate, it becomes ex squared times 2x, because the derivative of e to the power fx will be e to the power fx times f prime x. And if now we can check the limit of this term through the L'Hopital's rule, right? Now, we have rearranged the original problem and come to this stage, and we have differentiated the numerator and the denominator. Then from the L'Hopital's rule, it says the limit of this one is equal to the limit of this one. Now, what is the value of the limit of this new term? You can see again for this new stage, the stage 2, when you compute the limit, again it falls under the same situation. This is a very large positive number. This is e to the power very large positive number. So the result will be a very large positive number. And then again multiplied with a very large positive number, resulting in a very large positive number. Right? So again we have the same situation for the L'Hopital's rule. Now what we can do is, then again we can consider this as an original problem and apply the L'Hopital's rule one more time. So when we are applying the L'Hopital's rule for the second stage, or I mean for the second time, we can easily get it solved or simplified. See, now here we can, I'll write the limit x infinity, and I'll keep the 3 as it is, then 2 times x, and in the denominator you will get ex squared, and another 2x term is the derivative of this one, and okay, seems like I have I could have simplified these two terms in the beginning, and then it can come back to this one. Yeah. So I start from the second stage. So in the second stage, we can do some more simplification before applying the L'Hopital's rule one more time. So we can rewrite this one. I'm not applying the L'Hopital's rule. I'm just doing some cancellations in the top and the bottom. So here you have a 2x term and you have a x squared term. So what we can do is we can have the limit and cancel the 2x terms in the top and the bottom. So you will have ex squared. Then we can use the L'Hopital's rule. So upon applying the L'Hopital's rule, we can get the limit of this one, 3 to ex squared times 2x. So when you apply the limit, this becomes a very large positive number, this becomes a very large positive number, so the multiplication will again be a very large positive number. In fact, what you have is something like this, and the answer is 0.